Hello everyone, welcome to today's YouTube video on logarithm and the rules. In mathematics, we consider logarithm as the inverse function of exponentiation, if you like. So that we say that the log of a number, of a given number, say x, is the exponent to which another fixed number to a base must be raised to give that particular number x. So if we have log ax and we say that is equal to b, this implies that our x must be equal to a raised to power b. So to get the log of x for a particular base a, we must raise that base to a particular exponent b to get that number. That's what logarithm is all about. So that for instance, if we have log 10 100 and we say it's equal to b, this implies that 100 must be, and you know that 100 must be 10 raised to power b, and you know that 100 is equal to 10 raised to power 2, which means that our b is equal to 2. So that's it. So also, if we have something like log 3, log 9 base 3, so if you say it's also equal to, say, x, that means that what you are going to have is that 9 is 3 squared. 3 squared is equal to 3 raised to power x, which implies that x here also is equal to 2. Depending on the base, if it is 27 here, it will be x raised to power, that's 3 raised to power 3, and our x will be equal to 3. If it's 1000 here, it will be 10 raised to power 3, and our b will be equal to 3, and so forth and so on. So we have seen now that for a number a raised to power b giving us a particular number x, and we take log of both sides, taking log of both sides, will give us a log a particular base, say a, that a raised to power b is equal to log ax, and that's what it will give us, raised to power ax. That means that also from here we have found out that from here also that b, for us to get this, we did b is equal to log a, b equals to log a raised to power x, log x base a, log x base a, so that if this one comes here, it will take this shape. So you now see that from these two, for them to be equal, that means that our b, therefore b must be equal to log a raised to power b, and it's equal to, if you like, we have found that we will find it in time that log a is equal to 1, so that we have b. We find that log a base a is equal to 1, so that it is equal to b, like we started, b is equal to b. Also, this will tell us that if we substitute this, for this, if we substitute into here, we'll know that this is b. So if we put it here, we see that a log ax is equal to x. A log as is equal to x. So that if b is equal to 1, this implies that from here, if b is equal to 1 from here, you see that you have b. If b is equal to 1, therefore log b is equal to log a 1, and it's equal to answer 1. Therefore the log a is 1. That's a very important thing to note. 1 is equal to that. If b is equal to 0, it means that this implies that log a 0 is equal to log a 0 is equal to, you know that anything raised to the power 0 is 1, so it's log 1 base a. That's what it will give us, log 1 base a. And we will now see that log 1 base 0. So we know that from this identity, from here, if b is equal to 0, so that number will be 0. So it means that therefore 0 is equal to log 1 base a. So that is another important identity. Log 1 base a is equal to 0. So that's it. Now let us assume that u is equal to ax and v is equal to a raised to power y, a raised to power x and a raised to power y. This implies that, therefore, from what we have been doing before, it means that log u base a is equal to x and log v base a is equal to y. That's what it is. So that we now go to the rule 1, law 1, multiplication law. So if we have log, let's say uv, since we have defined what u and v are, base a, let it be equal to okay, let's say it's equal to w, but it's equal to a from here, ax, a raised to power y, and if you like, it's equal to log a into ax plus y. But let us assume that it's equal to w. Therefore ax plus y is equal to aw, which means our w is equal to, therefore w is equal to x plus y. Our w is equal to x plus y, and log uv is equal to log, because we have defined x to be equal to log u base a and y to be equal to log v base a. So that means that this is equal to log u base a plus log v base a. That's what it will give. So that is for multiplication law. So let us go to division law. That's law 2. 2 division law. Law 2 division law. So let us now also do log u over v, having defined u and v base a. So it will give us a log a raised to power x over a raised to power y base a, and you know what it means, log a x minus y. According to this is subtract their powers base a. That's what it will give. So that if we assume that it's equal to w in this case also, that means that a raised to power x minus y is equal to a raised to power w, and that implies that w is equal to x minus y, and that gives us that log u over v base a is equal to log u base a minus log v base a. That is our law 2. So let us go to law 3. I just categorize them. It's not that it must be law 3. Yeah, law 3 can be your law 1. Exponent. Let's see what happens with exponent. Exponents, that's indexes or indices. So law 3, let us check out, look at log u raised to power z. We have defined u to be equal to a raised to power x. So that is log a raised to power x raised to power z, if you like, base a. That's what it means. So this thing will give us log a raised to power xz. Remember product law in indices. That's what it will give us, and we have found out that log from here log aab is equal to b. So that means that our log AAXZ will give us XZ. So it's equal to X times Z. Will give us XZ. So that, and we know that X, look at it here. X here, X is equal to log u base a. So we are going to substitute log u base a into that place, and if we substitute it, we will have that therefore log uz base a is equal to z log u base a. That's what is going to give us. So that's an important property of logarithm. That's an important property of logarithm. Let us do one final one and call it law 4, if you like. So recall that we have said that log v base a is equal to log ay. From our division of v, our v is a raised to power y base a. So and this thing is equal to y log a base a, and it's equal to y. So it's equal to y. So we want to change that base now to b. If we change the base from a to b and write it like this, therefore log v base b will give us log ay, if you like, base b, and according to the indices we have done at log 2 or 3 or so, it will give us y log a b, y log a b. So that is what it will give us, which means that is equal to, so if we substitute for y, into that equation y that we have gotten before, look at it here. If we put y is equal to log v, in this case it will be vb because the base is b. If we put it there, it will be y will be log I said v base b times log a base b. That's what we will have. Log base b. That is what this will give us. This one. Once we interchange the base, we get that. That's what it will give us. This implies that log v base this is y is base a, log v base a is equal to log v base b all over log a base b. That is cross multiplying. This will go and divide that. So that's an important property we have to know also. Let me circle put it in a square closure. So that if we say now that v is equal to b, then that means what we are going to have is log va is equal to log b, because v is b over log a b. So this guy is 1. This guy is 1, like we know. So that we'll have that log va, therefore log va is equal to 1 over log ab. So that is a very important property, equal to log ab, log va. Okay, if we say that v equal to b, so here is b, here is b. If we say that v is equal to b, so good, ba is equal to that, and vice versa. So it's just to interchange the one up and down, and you get the correct result. So that is that. So we can show that as an example, we can show that log a plus b squared is equal to 2 plus log a into 1 plus 2b over a plus b squared over a squared, So in order to show that, we start from the right hand side. We know that these two, in order to put the log there, we must have something like log a squared to give us this first rule, So if we do that plus log all the other thing in the bracket, 1 plus 2b over a plus b squared over a squared. So what we will now have is, remember this is multiplication law, so we are going to use this to times this, so it's equal to log a into a squared plus 2ab plus this one we consider b squared. That's what we have. And you find out that if we factorize this, we will have is equal to log a into a plus b and a plus b. That's what we will have, and that is exactly what is on the left hand side, log a plus b all squared base a. So we have proven it. Thanks, and click the notification button to know whenever we have posted a new video, and please like the video. Bye.